more sophisticated robots need a detailed robot model. We need to explain the geometry. And ROS will enable to model very, very complex robots that have hundreds of parts. This doesn't mean the files are simple. The files can be very complicated as well. But you can model the geometry, you can model the mass properties, very important. If you want to be able to simulate dynamics, you need to know if I have a robot link, how heavy is it? What are the inertial properties, the rotation of inertia of the link? How does it behave? Is there friction? What are some different kinds of parameters? You have surface contact properties, talking about friction, Coulomb friction, or other kinds of friction. And then you have actuator dynamics, something like transmissions and other things like this. All of this can be specified in a file called Unified Robot Description File Format, URDF. Okay? So this is going to be a really important file for you. We're going to look at a lot of it. In the URDF, for physically realistic dynamic simulations, we're going to need 4 models that we need to work on. Dynamic model, mass and inertia properties, collision model, how does the system know when 2 links touch to make a collision, visual model, just how do things look, what is their color and their texture. Kinematic model is about kinematics, forward kinematics type stuff. How many links do you have? What are their connections? What is the direction of the joints? How do they move? Things like that. So these 4 things are included in a URDF file. Okay? Okay, so I mentioned that, inertial properties. Let me jump here. Collisions. In physics engines, you can have different kinds of engines. For example, Gazebo has all of these. Open Dynamics engine, sorry that doesn't look good. ODE, bullet, dart, symbolic. Different engines have different strengths and weaknesses. This one uses like ordinary differential equations. This one uses conservation of momentum. This one works well for short duration contact, but not well for long duration contact. Things like that. So if you care a lot about these things, you need to have a good insight about how the engine works and which one might be better for you. And people always continue to improve how these things work. In this class, we're going to use Gazebo 2. But these days you can also use Gazebo 8. The problem is it takes a lot of work to create models, right? So updating them and porting them to the latest edition is not easy. It requires a lot of work. If anyone wants to do it, the whole world will be happy to take your work in and use it, but it just takes a lot of work. So normally the robot models will lag behind the latest simulation editions. Okay? So visual models for graphical display. Many times the visual model and the collision model will be the same. Will be the same. And we'll explain more of this in a second. In the collision model, we also can talk about friction and resilience, color, reflectivity, transparency. We mentioned that. So let's look at an example here. Now, we're not going to start with a URDF file. We're going to start with another file called SDF, which is similar to the URDF, and it's originally designed to work with Gazebo. So we'll talk about it in a second. So we'll open this file from Package Example Models. We're going to look at this rectangular prism. Okay, so we can open it like this. The SDF and the URDF both use XML. XML is how can I describe it? Not a system, but a style of encoding information using tags. It looks a little bit like HTML if you have background with HTML. So XML is going to be used for SDF and URDF. And then right now, we're starting with inertial, collision, and visual. No kinematic model as an example. Then we will add the kinematic model, and we'll look at more complicated things. So let's open this file with me. Ross said example models, model 1.4.SDF. 1.4 SDF, 1_4 dot SDF, right? I put a point there. Oh, there's many of these here. Let's see, we're doing starting number 2. Okay. And then let's see. Okay, let's look at this very quickly. So anytime that something like this, you have something that starts and finishes with this, these are called tags. Okay, tags. And these will always start by saying this is an XML something something. For SDF, you set the version. Here we're using 1.4. And then every model has a name. We're going to start with rectangular. We're going to give this model the name rectangular prism. Okay, then you'll see that we have the 3 categories that we mentioned. Here we have a link, here we have the inertial tag that is going to belong to this link. In a second, we'll look at the collision tag, and finally, we'll look at the visual tag. Okay, so we have these 4 things right here. So we have a link. A link means maybe like this upper arm or this lower arm. Okay, that's a link, and we're going to give a mass. This is just an example in kilograms. 2,000 kilograms, and then this is a rotation of inertia. We're going to talk in more detail later. We need 6 numbers here to describe that. It's a matrix of 12, but 6 numbers are enough to describe it. Then we need the collision model. It has a name, and then it has a geometry. Here we have a box of 2 by 2 by 4, and this collision model will be similar to the visual model, which also has a geometry, a box, and a 2 by 2 by 4. Okay, this is just an example. Show it really quickly to you. Let's move slowly through the next part. Okay. We're gonna look at a robot description called minimal example. It's a 1 degree of freedom robot. Yeah, so it can rotate in one direction. It's a 1 degree of freedom. Then for your homework, you're gonna do the detailed example for a 2 degree of freedom arm. Okay, and the link is here, so you can click there and go to this tutorial. And so now we're gonna open up this links and joints URDF and minimal robot description. So we can say raw set, minimal robot description, links and joints. Yeah, just like this. Wind is falling asleep. I'm sorry, Wind. Yeah.